once again from Mission Control Houston, and welcome to our ongoing coverage of SpaceX's 13th resupply mission to the International Space Station. The Dragon resupply cargo craft in the grasp of the Canadarm2 robotic arm right now, and is just moments away from being attached to the International Space Station. You can see in the video right next to me, it's poised just outside of the port on Node 2, the Harmony module, where Dragon's going to soon be attached and will remain attached for the next several weeks until it gets ready to come home in mid-January. Control of the robotic arm is being remotely commanded by teams down here on the ground after the crews successfully captured the vehicle just a little while ago, just a little under 2 hours ago. As you can see, it's slowly driving towards that port now, and we do expect it to be in its position to latch, its ready to latch position in the not too distant future. And then once it's in place there, they'll be able to do the final capture stages, which will involve engaging a series of latches on the common berthing mechanism, the CBM, and then a series of 16 bolts, also known as A-bolts, which will firmly hold Dragon in place, and once those bolts have all driven, we'll consider the vehicle berthed to the International Space Station. So the teams here in Mission Control Houston overseeing the final stages as they work with ground controllers also in Canada to control the robotic arm to attach Dragon to the space station. As you can see, teams mostly out of Hawthorne now as they were responsible for overseeing Dragon's final flight to the International Space Station. All of this, of course, began at the end of last week, just 2 days ago, back on Friday, when Dragon lifted off from the Cape Canaveral Air Force Station in Florida. Dragon lifted off successfully at 10:36 a.m. Eastern Time, 9:36 a.m. Central Time, top of Falcon 9. This was actually a Falcon 9 that had already flown one resupply mission to the International Space Station before. The first stage previously used on SpaceX's 11th resupply mission back in June earlier this year. This was the first flight-proven booster, or reuse of a first-stage booster on a NASA resupply mission. The booster was successful, obviously, in its flight, and even landed back at landing zone number 1 following this successful climb to orbit.
Good afternoon, Mark.
Good afternoon to you as well. Just wanted to let you know that I went through step 3.3.14 in the Zebra fixed fan procedure, and this is the point of you making that report. Of course,
and that successful launch also set up the successful grapple, which came just a little under 2 hours ago. Dragon arriving and making its way towards the International Space Station, where 2 crew members, NASA astronauts Mark Vande Hei and Joe Acaba, were standing by. Vande Hei was prime at the controls for the capture, and Acaba was backing him up.
Go ahead, Leslie.
Hey, yeah, Mark. We are currently ahead about an hour on our timeline, and so we're about to enter into the no exercise constraint. We know that Joe is probably doing CVIS right now, and so we estimate at 12:55 that's when the no exercise constraint will go into place. So we're looking for your help if you can go find out if he would like to stop exercising and pick up later, or if we should wait until he's complete with his exercise.
There's a possibility he'll be done by then, but I'll check and I'll get right back to you.
Sure. Okay, copy.
And so while the folks here at Mission Control Houston confer with the astronauts on board, this is a view from just a few hours ago as again Dragon was captured successfully at 4:57 a.m. Central Time, 5:57 a.m. Eastern. Mark Vande Hei at the controls of the space station's robotic arm, reaching out and grappling with the Dragon spacecraft while it was in free drift, just a little over 10 meters away from the International Space Station.
Starting until after Joe is complete with Cetus. He'll be done probably within a couple minutes of when you intended to be ready.
Okay, we copy that. Not a problem. And just give us a call when you think we're ready to pick up again.
Sounds great. Thanks.
And so as we just heard, radioed up, the ground team's moving about an hour ahead on their timeline, so we should hopefully get Dragon berthed ahead of schedule and wrap up all of the operations with this vehicle for this morning. There are exercise constraints, so essentially the crew members, when they exercise, can actually impart some vibrations and therefore some loads onto the station itself. And so whenever doing some of the more delicate operations like berthing a vehicle, they do have the crew stand down from exercise. They are, again, ahead of the timeline right now. And so actually in the crew's exercise period, so they're going to wait for Mark Vande Hei to wrap up his exercise and then continue on with attaching Dragon to the International Space Station. And so right here, Dragon only about 1.5 meters away from its berthing port on the Earth-facing side of the Harmony module. So again, right now, Dragon is only about 1.5 meters away from that berthing port. It's just going to stay in this configuration for a little while, as there is an exercise constraint for the next stages of attaching Dragon to the station. So once the crew is wrapped up with that, the robotics controllers here on the ground will be able to continue on with the maneuver and get Dragon attached to the Earth-facing side of the Harmony module. So on board the SpaceX Dragon, it's packed with just around 4,800 pounds of cargo. In the interior pressurized section, it's broken down by all of these different items, crew supplies, your general things like food, clothing, and other perishable items for the crew. Science investigations over 1,500 pounds worth, supporting dozens of different experiments that'll take place on board the International Space Station. And then a lot of that science actually coming home on Dragon, as SpaceX's cargo capsule is currently the only resupply vehicle capable of surviving the re-entry through the Earth's atmosphere and returning science samples and science hardware. It's also a little over 360 pounds of spacewalking equipment, an entirely new EMU spacesuit on board for the crew members, and over 400 pounds of vehicle hardware. That's just spare parts and other items for the station itself. And then the computer resources, typically batteries, cables, and other items like that for the IT infrastructure on board the station. And in the unpressurized payloads, the trunk, 2 science payloads that are going to be installed on the outside portion of the International Space Station. All of that together breaking down for a little over 4,800 pounds, or over 2,200 kilograms. As mentioned, some of those payloads, the external ones, are going to be installed outside, and they'll be extracted from Dragon's trunk robotically in the days to come. The first of which, the space debris sensor, is actually going to be measuring the debris of an environment around the International Space Station. It's going to be mounted on the exterior, and the payload itself is about 1 square meter, and the sensor will provide near real-time debris impact detection and recording. And these debris items, not to scale, but the debris environment in low Earth orbit, a threat to pretty much any spacecraft that's up there flying, and debris ranging from something as small as a fleck of paint to as large as a spent rocket body. And so results from this investigation hopefully lowering the risk posed by those orbital debris, not only to the astronauts flying, but also the spacecraft that they're in. This is actually an image of a window in the station's cupola that took a small orbital debris hit. The International Space Station, the most heavily shielded spacecraft ever flown, capable of withstanding direct hits by debris as large as 1 centimeter in diameter. And then for items 10 centimeters or larger, we're able to track that with the assistance of the Strategic Command here in the United States, and then maneuver the International Space Station out of the way. But this space debris sensor just going to further characterize the debris environment in low Earth orbit, and again, hopefully lower the risk posed by those debris. The other external payload on board that's going to be installed on an external logistics carrier is the TSIS-1. It's NASA's Total and Spectral Solar Irradiance Sensor, and that's going to be measuring the sun's energy input into Earth. Its measurements will be 3 times more accurate than any previous capabilities, and these types of measurements going back over 40 years, but this enabling scientists to study how the sun's natural influence affects the Earth's ozone, atmospheric circulation, clouds, ecosystems, the climate as a whole. These observations essential for a better scientific understanding of the effects that solar variability actually has on the Earth's system. And back with the live view, you can see just how close Dragon is. And again, once they move it in the final stretch, it's about 1.5 meters away right now, but it'll engage the common berthing mechanism, the part on the International Space Station. The series of latches will engage for a first stage capture, and then a series of A bolts, 16 bolts, will engage to really put a hard mate onto the Dragon vehicle, and at that point we will consider it berthed and attached to the International Space Station. And so a short handover between communication satellites with the International Space Station. The Orbit 1 team still on console here. They came on a little bit early just to get ready for not only this SpaceX operations late last night, but also a Soyuz launch, as we've actually seen 2 spacecraft in the mix in the last couple of hours. The crew successfully launching from the Baikonur Cosmodrome in Kazakhstan, carrying the 3 newest Expedition 54 crewmates. Nori Kanai, Scott Tingle, and Anton Shkaplerov are in orbit and chasing down the International Space Station, and they'll be catching up on Tuesday. But for now, our eyes trained on this SpaceX Dragon, currently very close to being attached to the station, and hopefully should be getting into those final phases soon. And we looked at some of the external payloads that were delivered by the Dragon spacecraft. There's also a number of internal payloads in the pressurized section, over 1,700 pounds of science packed away inside of Dragon. One of which going to be taking a look at potentially manufacturing in low Earth orbit, taking advantage of that microgravity laboratory. Why don't we take a look at this, a payload made possible by the National Laboratory, a commercial company doing research in microgravity.
We're excited at Made in Space to work with NASA and CASIS to use the ISS National Lab. Made in Space fiber optics is a payload to manufacture Z-band glass fiber in microgravity. It will produce hundreds of meters of very, very high-end optical fiber. Manufacturing fiber in microgravity has been theorized to increase the performance by creating a better product. And by better product, I mean a clearer, more pure glass. And that is due to the microcrystal formation. It makes the glass a little cloudier when the crystals form here on Earth. And in space, it'll be more pure and clear. And in microgravity, they form in a different way, in a more pure way with fewer defects. What could happen is a 100-time increase in performance. This is a really cool project because it can benefit everyone here on Earth. You know, fiber optics are used for various applications, medical devices, lasers, but also internet. And this can really help, improve bandwidth and performance and lower the cost of internet and data centers. So really, it's a product that can affect everyone.
And that was just a quick look at just one of the many research studies being delivered aboard SpaceX's Dragon. The research on board running the gamut from biological studies to technical demonstrations to manufacturing, like the fiber optic payload we just saw there. And that one from a commercial company, Made in Space, made possible by half of the U.S. allocation of research space on the International Space Station being made available as a U.S. national lab. That meaning commercial companies, academia, and other government agencies getting a chance to fly their research on board the International Space Station. That national lab managed by the nonprofit CASIS, the Center for the Advancement of Science in Space. The Orbit 1 team getting a quick breather while we had that comm handover between satellites. Should be reacquiring the video communication with the International Space Station shortly. And again, once we do, Dragon poised about 1.5 meters away from the common berthing mechanism on the Earth-facing side of the Harmony module. And once we get past the crew exercise period and can put those constraints in place, they should be able to continue on. And again, they'll continue moving Dragon in the rest of the way, and we will have a first stage and a second stage capture. First, a series of latches will engage and attach Dragon to the common berthing mechanism, and then a series of 16 A-bolts will move into place, giving a second stage capture and a hard mate for Dragon, holding it in place, and that's when we will consider it attached to the International Space Station.
The station on Space to Ground 2. Joe is done with exercise, so we're go for adding an exercise constraint.
And we copy and much appreciate. Thank you.
Thanks for the flexibility.
And we're back with this HD view of Dragon still attached to the end of the Canadarm2 robotic arm. It was captured just about 2 hours ago by NASA astronaut Mark Vande Hei, who was primed for the capture. Since then, ground controllers have maneuvered Dragon to where it now resides, just 1.5 meters away from its final berthing port. And with the exercise on board now complete, should be able to put that constraint in place and then begin moving Dragon in. And we can see with the arm in motion, Dragon now closing in on that Earth-facing port on node 2. So Dragon inching in now, moving very close. And this will be a two-stage process once it actually gets attached to the common berthing mechanism. First, a series of latches holding it in place, followed by those 16 bolts to perform a hard mate, and that's when capture and installation will be complete.
Station Houston on 2 for an available crew member and gem and cupola window shutters.
Go ahead, Leslie.
Yeah, just want to give you a heads up that the gem and cupola shutter constraint is actually 15 minutes longer, and that will actually end at 14:05.
Happy. We will agree not to open shutters without calling you first.
We like that plan. Thank you.
as you can see, getting very close now to the installation of Dragon to the Earth-facing side of the Harmony module. Very small distance to go. Once it's actually attached to the common berthing mechanism, a series of latches will first hold it in place, followed by 16 bolts, which will perform a hard mate, and then we will consider the installation complete. So continuing to stand by, the robotics ground controller slowly moving Dragon in. We should be wrapping up in the near future. And so the robotics officer here in mission control reporting they're about to execute another maneuver. Should get us into what's known as RTL, or ready to latch. And that'll be a very good sign, as once it's in ready to latch, the latches on the common berthing mechanism will be able to engage, and then followed closely thereafter by those 16 bolts. So standing by, should see some movement shortly, and get one step closer to finishing the installation of Dragon. As you can tell from your view, Dragon just about on that common berthing mechanism. Will stand by to confirm that it's in the ready to latch position, and that'll signal that the final stages of installation can pick up. And getting confirmation here in mission control, we are in that ready to latch stage. So now just standing by for the final stages, the latches on the common berthing mechanism as well as the A bolts, the 16 bolts, will be engaged to hold Dragon in place, and then we will be done and Dragon will be installed to the International Space Station. And again, we're standing by, Dragon currently in the ready to latch stage. The first stage capture will come first. And looking like that first stage capture in work. Now some configuration on the robotic arm. And then the second stage capture and the A bolts, 16 bolts that are engaged to hold Dragon in place will come next. And then Dragon will be installed on the International Space Station. The robotic arm now configured should be working second stage capture now. So again, at this point, first stage capture already confirmed. These 16 A-bolts now being put into place to put Dragon securely held in this common berthing mechanism, the port on the Earth-facing side of Node 2, the Harmony module. And once we get confirmation that those bolts have been put in place, the installation will be complete, and Dragon will be firmly attached to the station. And while we continue to stand by for second stage capture, the International Space Station just about to make a pass over Puerto Rico, currently flying at an altitude of 252 statute miles. Flight controllers here in Houston confirming the A-bolts now in progress, driving into place. So again, we're continuing to stand by. We did hear confirmation that the bolts are starting to drive. There's 16 total. They're referred to as the A bolts. Once these are in place, Dragon will be installed, and it will be there for the next several weeks.
Station Houston on 2 for Mark and Timeline.
Go ahead, Leslie.
Hey, I've got good news for you. We're about over an hour ahead on the timeline. A bolts are complete, and so we're going to need another hour to complete the bolt loading. At that time, we estimate at 14:30, you will have a start for the Node 2 vestibule pressurization.
Wow, 14:30 as in about 3 minutes from now? I need to learn how to read a watch. That's about an hour from now. Copy.
Okay, we're all on the same page. That's good.
And as you just heard in the call from Capcom Leslie Ringo,
This is awesome.
again, as you just heard from Capcom Leslie Ringo, the A bolts in place, Dragon installed to the International Space Station. We got the call on the flight loop at 7:26 a.m. Central Time, 8:26 a.m. Eastern Time. while the station was flying 254 statute miles over the northern Atlantic. So again, Dragon installed 7:26 a.m. Central, 8:26 a.m. Eastern. SpaceX's 13th resupply mission installed now to the International Space Station. With that, the crew's now going to rapidly move forward with some preparations around the common berthing mechanism and actually look to get the hatch open today and begin unloading cargo. It's going to be a fast and furious task for these crew members over the next couple of weeks as they work to complete a lot of the research delivered on Dragon that's ultimately also going to be delivered back down to Earth, along with a number of other science samples. Dragon, the only resupply spacecraft right now capable of surviving the trip back through the Earth's atmosphere, and vital for returning scientific samples from a wide array of research done on board the International Space Station. With that, though, we are wrapping up our Dragon coverage for this morning. So I do want to thank you for joining us. We are going to be coming back in just 2 days on Tuesday for the docking of the Soyuz MS-07, currently in space chasing down the International Space Station with 3 new crew members. That vehicle scheduled to dock at 2:43 a.m. Central Time, 3:43 a.m. Eastern, Tuesday, December 19th. So tune back in 2 days for a little bit more space action and more traffic on board the International Space Station. And I want to thank you for joining us for all of our broadcasts this evening and this morning. Successful SpaceX arrival and installation on the International Space Station. With that, we will sign off one final time this Sunday. This is Mission Control Houston.
Houston Station on Space to Ground 2 for iPad.
Go ahead for iPad.
Hey, Leslie, our iPad Air 2, serial number 1008, which we've dubbed the Loadmaster iPad. The file browser app crashes. So when we try to open it, it just closes right after we see the open screen. That's the iPad we ideally use to keep track of how we're doing with cargo ops, and File Browser is the app we use for that. So if there's any help you can get us with being able to use File Browser on this, it would be great. In the meantime, we'll be able to use other iPads.
Okay, copy. We will put words together for you on that. Station Houston on 2 for Mark and iPad troubleshooting.
Go ahead on 2, he's listening.
Hey, I was curious, have you guys done any troubleshooting